Today I'm going to present the presentation for my dissertation, and as Joe said, it's called Valuing Residential Energy Efficiency in Two Alaska Real Estate Markets, and I use the hedonic approach. First, I'd like to thank my committee, so my chair, Dr. Joe Little, Dr. Amy Lovecraft, Dr. Miller Stoffels, and John Ho, who can't be here today. I'd like to thank my funding sources, the Alaska Center for Energy and Power, and the Resilience and Adaptation Program that have funded me throughout the entire course of my program. I'd like to thank the data sources, the Alaska Housing Finance Corporation, the Coal Climbing Housing Research Center, the Alaska Multiple Listing Service, and West Madden Real Estate. I'd like to thank the faculty and staff at the Alaska Center for Energy and Power for all of their support and encouragement. In particular, I'd like to thank Marcia Casino, who's been my biggest cheerleader, and our director, Gwen Holdman. And last but not least, I'd like to thank my family and friends. In particular, I'd like to thank the Steffes family and Eric Johnson. So for an overview of the presentation, first I'll give some general background information that pertains to all of the studies. And then next I'll cover my first study, which examines how participation in the Alaska Home Energy Rebate Program affects property prices in the Fairbanks North Star Borough using a OLS hedonic model with both a full sample and a propensity score match sample. The second study examines how participation in the rebate program affects property prices in the municipality of Anchorage. And in that chapter, I use an OLS hedonic model with a full sample and a propensity score match sample. And I also use a difference in difference estimator. The third study examines the relationship between energy efficiency ratings and the transaction prices of residential properties in the Fairbanks, North Star Borough, and the municipality of Anchorage real estate markets. And in that chapter, I use both an OLS hedonic model and a robust estimator. So the problem. Alaska has a cold climate. Nearly the entire state is covered by either a subarctic climate zone or an arctic climate zone. And we also have high energy prices. We have some of the highest energy prices in the nation. Alaska is one of 9 states that does not have a mandatory energy efficiency standard. We do have a voluntary energy efficiency standard, but it was not built or was not implemented until 1992. And nearly 75% of the housing stock in Alaska was built prior to this energy efficiency standard being implemented. So, because of the inefficient housing stock and our high demand for energy and high prices, Alaska households have energy costs that are double the national average. And when a household has high energy costs, that can lead to fuel poverty, which is when a household spends 10% of its income on home energy, which includes space heating to heat the interior of the home, electricity for lighting and appliances, energy used for cooking, and domestic hot water. And fuel poverty is the result of low incomes, high energy prices, and inefficient housing stock. So as we all know, the Alaska economy is linked closely to the boom and bust cycles of the oil industry. When oil prices are high, that's good for the state's budget because the state brings in a lot of revenue. However, these high oil prices also place a large burden on homes that rely on petroleum-based fuels to meet their home energy needs. And high oil prices are especially burdensome in rural areas of the state that rely on diesel for both electricity generation and space heating. So as oil prices reached record highs, the Alaska State Legislature appropriated $300 million to 2 residential energy efficiency programs in 2008, the Alaska Weatherization Program and the Home Energy Rebate Program. And increasing the residential energy efficiency of one's home can reduce your energy expenditures because it requires less fuel to heat your home to a comfortable temperature. And since you're using less fuel, you also emit fewer CO2 emissions. The weatherization program is a jointly state and federally funded program. It provides energy efficiency upgrades to dwellings at no cost to the homeowner or a renter as long as they meet income qualifications. For homeowners that exceeded the income qualifications, the state established the Home Energy Rebate Program, which I'll refer to as the rebate program throughout the rest of the presentation. This program was established to incentivize homeowners to invest in residential energy efficiency measures. It was administered by the Alaska Housing Finance Corporation from 2008 through March of 2016, when the program was suspended due to budgetary shortfalls. And through the Home Energy Rebate Program, homeowners could receive a rebate for up to $10,000 for making pre-approved energy efficiency upgrades to their homes. The amount of the final rebate check that a participant got was based on the improvement in the home's energy rating between the as-is energy efficiency audit before they made any energy efficiency upgrades, and the post-improvement audit after the upgrades. And also the rebate was based on receipts for labor and any material costs. Over the life of the program, nearly 25,000 Alaska households participated in this program across the state, and it is estimated that program participants reduced their annual home energy costs by 30% and their CO2 emissions by 35%. So both the weatherization program and the rebate program required participants to undergo both an as-is energy audit before the retrofit was conducted and a post-improvement audit. And during these audits, an energy auditor came to the home and they used engineering software called AK-WARM to model the energy efficiency of the home. And after they entered in all the information, the home would be given an energy rating score based on a blower door test, combustion safety test, and a ventilation assessment. And this score is based on a 0 to 100 plus point scale, which corresponds to star ratings. So the lowest energy rating is 1 star, and as the points awarded to a home by the auditor increases, so does the star rating. So the rebate program and the weatherization program provided me with a research opportunity. So when you make energy efficiency improvements to a home, not only do you reduce your fuel costs and your CO2 emissions, but improving the energy efficiency of a home can also increase its transaction price if the energy efficiency measures are capitalized into the value of the home. So I know that all rebate participant homes underwent an energy efficiency retrofit. So this provides me with a research opportunity to investigate how energy efficiency retrofits affect transaction prices across the state in various real estate markets. And then the energy efficiency ratings that were awarded during the energy efficiency audits for program participants for both the weatherization program and the rebate program, that provides a research opportunity to investigate the relationship between the energy efficiency ratings of homes and their prices. So obviously I did a lot of literature review before I started my own research, and I found that the establishment of energy efficiency standards and certifications have made it possible to study the relationship between energy efficiency and real estate transaction prices in different markets across the world. In the United States, most of the research focuses around the Energy Star program and the LEED program. The Energy Star program was started by the EPA in 1995. And this is not to be confused with the star ratings that we use in Alaska. These are two totally different programs. The Energy Star program is dichotomous, either you are certified or you're not certified. And properties that were certified in the literature command a 1.2 to 4.9% price premium over non-certified properties. For LEED, which is the Leadership in Energy and Environmental Design, this was established by the U.S. Green Building Council, and it's broken out into levels. The lowest level of certification is just LEED certification, and then it goes up to silver, gold, and platinum. And in the literature, LEED certified properties command a price premium between 5.3% and 8.9%. Across the United States, there are several cities and states that have their own green certifications, and I found that through these various certifications, homes that were certified commanded a price premium between 3 and 8% compared to non-certified properties. Throughout European markets, most studies focus on energy performance certificates, and all properties that are built, sold, or rented in Europe are required to have an energy performance certificate. And these are in levels 2, from A for the most energy efficient properties to G for the least. And these have been mandatory since the EU Energy Performance Building Directive of 2003. And in the literature, I found that energy performance certificate properties sold for a price premium between 1.5% in Helsinki, that was the low I found, to 25% in Ireland. Singapore has its own energy certification program called Green Mark, and it's very much like the LEED certification. It's broken out into levels. And in the Singapore market, compared to non-certified properties, Green Mark properties command a price premium between 4% and 13%. And Platinum, which is the highest rated properties, when the properties were broken out by their levels, commanded a price premium between 14% and 28% compared to non-certified properties. So one thing that all of the literature has in common is they all use the hedonic pricing framework, which was established by Rosen and Friedman around the same time in the 70s. And through this framework, it looks at a house as the house price is a function of its characteristics, so its structural characteristics such as bedrooms, bathrooms, its locational characteristics such as the neighborhood in which it is located, and environmental characteristics such as the air quality in the area it's located in. So pH is the implicit price function, and each of the characteristics are in this implicit price function, and you can figure out the implicit price of any given characteristic by differentiating the implicit price function with respect to that characteristic. And what I'm interested in, the characteristic I'm studying, is energy efficiency. The significance of this research, there's a small body of literature investigating how residential energy efficiency affects property prices in cold climate regions, so regions with subarctic and Arctic climates. And the reason that this is important is that homes in cold climate areas use more energy than homes in warmer areas, so even small improvements in energy efficiency can lead to significant cost savings. These are the first studies to estimate the impact of the rebate program on property prices in Alaska. No other study has been able to do that before, and this is the first study that investigates the relationship between energy efficiency and transaction prices, or energy efficiency ratings, excuse me, and transaction prices in Alaska property markets. My first study is the value of residential energy efficiency in interior Alaska. My research question is, does rebate program participation affect transaction prices of homes in the Fairbanks real estate market? And that translates into the testable hypotheses, the null hypothesis. Rebate program participation has no effect on transaction prices of homes, and the alternative hypothesis that rebate program participation has an effect on the transaction prices of homes. Here's a map with the Fairbanks-North Star Borough shaded in yellow. As you can see, it's in the interior region of the state. Some statistics on the study area. The borough has 98,000 residents, 32,000 of which live in the city limits of Fairbanks. We have a subarctic climate, and annually we average over 13,000 heating degree days. And a heating degree day is a measure of the average daily temperature minus a base temperature. And it's usually 65 degrees, and the reason it's 65 degrees is when it's 65 degrees outside, you don't have to turn your heating on. And so that is the daily heating degree days, and then you sum that over the entire year, and you get the annual heating degree days. As I mentioned earlier, our housing stock precedes our environmental or our energy efficiency standard, or voluntary energy efficiency standard. More than 75% of our housing stock is more than 25 years old. Household energy costs annually are about $8,000, and that includes electricity. And so our energy costs are about 4 times the national average. In Fairbanks, roughly 90% of households use heating oil for space heating, and 73% of households use heating oil as their primary source of heat. 80% of household energy consumption in Fairbanks is dedicated to space heating compared to the national average of 42%. And on average, our average energy rating for the housing stock in Fairbanks is 3 stars. This is the distributions of the energy ratings of homes both before and after completing the rebate program. Pre-retrofit is in blue and post-retrofit is in red, and you can see that the density of this shifts over, so the homes that participate in the program are on average more energy efficient. And there was a 1-star improvement, an average of 1-star improvement. In this chapter and in the rest of my chapters, I use ordinary least squares to estimate models. OLS is a statistical method for estimating the parameters of a linear regression model. And what I'm interested in is you have a cloud of data, and so what you're trying to do is minimize the sum of the residuals. So your model is going to be drawn through this cloud of data, and the goal is to minimize the sum of the residuals from the predicted value of what your model predicts and the actual observed value. OLS, it requires some underlying assumptions to be met. One is that your model is linear in the parameters. 2 is that it's drawn from, your sample was drawn randomly. If you have more than one independent variable, they cannot be perfectly collinear. And 4 is that based on your independent variables, conditional on those variables, your mean of your errors has to have a zero conditional mean. So those 4 assumptions are needed to make sure that your estimates, your beta estimates, are unbiased. And then there's a 5th assumption, which is that the variance of your errors is constant, that it doesn't grow or shrink over values of x, and that is required for your standard errors. And so for hypothesis testing, you would need to assume homoscedasticity. So this is the first econometric model. I'm going to go through this slowly, and then for the next models, I'll just explain the difference between the difference from this model. So the natural log of the transaction price is the dependent variable. Alpha is a constant, and epsilon is an error term. X is a vector of house characteristics such as bedrooms, bathrooms, square feet. A is a set of binary variables for the MLS area, that's the multiple listing service. And the reason I use that instead of zip codes is that there are more MLS areas, so it gave me better resolution. So if a home is in MLS area, let's say Chena Ridge, that would take a value of 1, 0 else. Y is a set of binary variables for the transaction year. It'll take a value of 1 if the home sold in that year, 0 else. Q is a set of binary variables for the transaction quarter. It'll take a value of 1 if the home sold in that quarter, and 0 else. And then our variable of interest is is R, and that is a binary variable for rebate participation. And so psi is the parameter of interest, and that can be interpreted as the average percentage price premium estimated for a home that completed the rebate program. Because it's possible that homes that opted into or selected into the program were somehow different than homes that did not select into the program, I use propensity score matching. And propensity score matching makes it so that the treatment group and the control group are more comparable by controlling for the home attributes that may affect whether a homeowner selected into the program. And this can help reduce selection bias. And what propensity score matching is, first, a logit model of the likelihood of participation of a home participating in the program is estimated using the home attributes and the MLS area. And then these predicted propensity scores are used in an algorithm for 1 to 3 nearest neighbor matching. So each rebate participant house is matched to 3 homes that are structurally and spatially like that. So homes on Chena Ridge with 3 bedrooms and 3 bathrooms would be matched with other homes on Chena Ridge with 3 bedrooms and 3 bathrooms. And that is just a way to try to make sure you're comparing apples to apples. Here are the means for both my full sample and my propensity score match sample. These are the independent variables for the housing characteristics that enter into that vector. So I have square feet, bathrooms, bedrooms, garage capacity, which is how many cars a garage can hold. Heated garage is a binary variable for whether or not a home has a heated garage. The age of the home, the elevation of the property parcel, and the acres of the property parcel. Data for this chapter and for each of the remaining chapters are from the Alaska Multiple Listing Service, the data on the property transactions, and data for rebate participant properties is from the Cold Climate Housing Research Center, which maintains the ARIS database on behalf of the Alaska Housing Finance Corporation. So if you look at the group means for these, some of them are pretty different, but where the use of the propensity score matching really becomes evident is when you compare the treatment group to the control group. So the treatment group in both the full sample and the propensity score match sample are going to be the same. However, the control group will not be the same. And so here I've done t-tests on the group means for each variable for both the full sample and the propensity score match sample. And you can see that the group means for bedrooms, garage capacity, heated garage, and age are statistically different for the full sample, but with the propensity score match sample, they are no longer, the group means are no longer statistically different than the treatment group means. So that shows us that we are in fact matching apples to apples. So because I used a log level model specification in order to interpret the coefficients, the model coefficients, which we'll call beta, for continuous variables like age, it's just 100 times the beta coefficient. But for binary variables, Halvorsen and Palmquist showed in their 1980 paper, their seminal 1980 paper, that the proper interpretation for binary variables is 100 times e to the beta minus 1. So the results for the full sample. in the full sample, homes that completed the rebate program sell for a 15.5% price premium over similar homes that did not complete the program. And at the mean price in the full sample, that equates to about a $36,000 price premium. And this model has an R-squared of 0.6, which means that 60% of the variation in the data is explained by my model. So for the propensity score match sample, I found that homes that completed the rebate program sell for 15.1% price premium over similar homes that did not complete the program. And at the mean selling price for a home in that sample, that equates to a $35,000 price premium. So according to independent reports, I do believe this piece of information is from the Alaska Housing Finance Corporation. Across the state, the average rebate participant spent about $11,700 on their energy efficiency upgrades before they received their rebate check. And the average rebate for the Fairbanks North Star Borough was about $6,400. And after the $500 reimbursement, that makes it so the average out-of-pocket investment for a rebate participant in the Fairbanks North Star Borough was $4,800. Since homeowners that complete the program are expected to save 30% of their annual energy costs, that equates to a $2,400 annual energy savings. So it would take a homeowner less than 2 years to recoup their private investment in energy savings, and it would take less than 5 years to recoup the combined public and private investment in energy savings. So the premiums, the participants received a premium of over $35,000. So that tells me that even absent the rebate program, it would make sense for homeowners to invest in energy efficiency measures because the premium exceeds the installed costs of the measures. So if a home buyer would have purchased one of these homes after the home finished the rebate program, they would have to occupy that home for 15 years to recoup the price premium they paid through energy savings. The second chapter is the value of energy efficiency in the Anchorage residential property market. And in this chapter, the research question I'm trying to answer is, does the rebate program participation affect the transaction prices of homes in the Anchorage real estate market? Here's a map of the municipality of Anchorage shaded. It's located in south central Alaska. The Anchorage study area. Anchorage is by far the state's largest city. It has over 300,000 residents. Like Fairbanks, it has a subarctic climate. However, Anchorage has a maritime influence, which makes it so they have cooler summers but also warmer winters. They average 10,570 heating degree days annually, and more than 80% of the housing stock in Anchorage is more than 20 years old. 71% of households in Anchorage, 71% of household energy use is dedicated to space heating, and that's compared to the national average of 42%. So it is still quite a bit above the national average. Energy costs in Fairbanks or Anchorage are about $2,800 annually, and that is 30% above the national average. And in Anchorage, 90% of households use natural gas for their home heating. Like Fairbanks, Anchorage, the average energy rating of properties in Anchorage is also 3 stars. So here is the distribution of the pre and post retrofit energy ratings for Anchorage. In blue is the distribution for pre-retrofit energy ratings, and red is the post. And as you can see, the distribution is shifted. The weight of the distribution is shifted. The density of the distribution is shifted. So this is almost identical to the econometric model I used in the previous chapter. The parameter of interest is R, or the variable of interest is R, which is a binary variable for whether or not a home participated in the rebate program. So because I had enough data, I could, for repeat sales, I didn't have enough for Fairbanks to do this, but for Anchorage, I was able to use a difference in difference model. And what this does, it makes it possible to determine if there was a significant difference between the value of rebate participant and non-rebate participant homes before they ever underwent the energy, before the rebate participants ever had the energy retrofit. So at the time of the first sale, no homes had participated in the rebate program. But at the time of the second sale, the homes in the treatment group had participated in the rebate program, and homes in the control group had not. Another nice thing about this model is it allows you to capture the price appreciation or depreciation trend in the all housing values across a study area over the study period. So these are in my previous models. What's different about this, these are the three variables that are different. So participated is a binary variable for whether someone has participated or will participate in the rebate program. And second sale is a binary variable for if it's the second sale of the property. And then post-rebate is an interaction term between participated and second sale. The parameter meanings. So this accounts for the difference between homes that did and did not participate in the rebate program. Omega accounts for the changes in all housing values between the first and the second sale. And then our major parameter of interest is going to be delta, which measures the impact of participating in the program on transaction prices. And what delta is the difference in difference estimator. So we have program participants at the time of the second sale and the first sale, and then we have non-participants at the second sale and the first sale. And so what this does is it measures the difference in the average value of rebate participant homes between the first and second sales, and then it subtracts from that the difference between the average values of homes that did not participate in the rebate program between the first and second sale. And that's how it brought the name difference in differences. You're taking the difference and then you're differencing that. So in this chapter, I have three samples. I have the full sample, the propensity score match sample, and the repeat sale sample. The independent variables for the house characteristics are square feet, bedrooms, bathrooms, garage capacity. Condo is a binary variable for whether or not a home is a condominium, age, and the acres of the property parcel. So for the Anchorage housing market with the full sample, I found that homes that participated in the rebate program sell for an 11% price premium, and at the mean price in that sample, that equates to a price premium of about $34,000. With the propensity score match sample, I found that homes that participated in the rebate program sell for a price premium of 10%, and at the mean value of a home in that sample, that equates to a premium of about $34,000 as well. For the difference in difference estimator model, homes that participated in the rebate sample or in the rebate program on average were worth 5% more at the time of the initial sale. So homes that opted into it were worth 5% more before they ever even underwent the retrofit program. In Anchorage, over the study period, there was an 8% increase in housing prices over the study period, and then the coefficient of interest is post-rebate, and that tells me that homes that participated in the rebate program sell on average for 5% more than homes that did not, and at the mean price in the repeat sales sample, that equates to a price premium of $15,300. So since the average Alaska rebate participant spent about $11,700, and the average Anchorage rebate participant received a rebate of $7,400 after their $500 reimbursement for the energy audits, Anchorage participants had an average out-of-pocket investment of about $3,600. Since a rebate participant can expect to save 30% of their annual energy costs, that equates to an expected annual energy savings of about $800 for Anchorage residents. And so it would take an Anchorage resident about 4.5 years to recoup their private investment and about 14 years to recoup the combined public and private investment. So people that participated in the rebate program and subsequently sold their homes received a price premium between $15,000 and $34,000. As you can see, that premium exceeds the installed cost of the measures. So even absent the rebate program, it makes sense to invest in energy efficiency measures in Anchorage. That's what my results show me, as long as you didn't spend more than $11,681. If a person who purchased one of these homes after they went through the rebate program, if they did in fact pay the price premium of $15,000 to $34,000, it would take a home buyer roughly 18 to 40 years to recoup their the price premium through energy savings. The last chapter is the value of energy efficiency into Alaska property markets. And in this chapter, I'm interested in investigating if energy efficiency ratings have an effect on the transaction prices of homes in Anchorage and Fairbanks and their housing markets. And this one's different from the first two because in the first two chapters, it's just whether or not you participated in something. But in this chapter, all homes presumably fall somewhere on that 1 to 6 energy star rating scale. And so this tells you how moving from one star to the next star, the value that is associated with that. So once again, here's a map with Fairbanks and Anchorage shaded in. To compare the study areas, Fairbanks is more rural than Anchorage, which will definitely have an effect on the property market. Fairbanks is quite a bit colder than Anchorage. We have 23% more heating degree days annually. Because we don't have that maritime effect on our climate here like Anchorage does, we have colder winters and warmer summers. Our annual energy costs are about 3 times greater than the energy costs in Anchorage. And compared to the national average of 42% in Fairbanks, 80% of household energy, annual household energy is dedicated to space heating compared to 71% in Anchorage. Also, few Fairbanks residents have access to natural gas. Some do here, but most people in Fairbanks are using heating oil. So this is not the data that I worked with. This is from the ARIS database. But what we have here is the mean 1,000 BTU per square foot for homes that fall into these categories. And blue is Anchorage, red is Fairbanks. And homes are sorted by how much energy they're using. So it's not surprising that this looks like this. What's more surprising is the estimated annual energy cost of homes in the ARIS database. So this is based on the average size home in the database for Anchorage, which was 2,177 square feet, and the average size home for Fairbanks, which was 2,163 square feet, and also based on current energy prices for the cities. In Anchorage, the current energy price for electricity is roughly 17 cents per kilowatt hour, and natural gas is $9.64 per MCF. In Fairbanks, electricity is about 20 cents per kilowatt hour, and a gallon of heating fuel is $2.65. So in this model, the variable that we're interested in is the energy efficiency rating of a home in points. So when the energy efficiency auditor comes and rates the home, the points equate to the rating level. So this is the 1 to 100 plus points rating. And the parameter that I'm interested in measures the average percentage increase in the price premium of a home associated with a 1 point increase in that energy efficiency rate, or the energy efficiency points assigned to a home during an energy efficiency audit. In my second model, this variable has been broken out into a set of binary variables for 1 through 6 stars. So they take a value of 1 if the home falls into that category, 0 else. And the parameter of interest measures the average price premium associated with an energy efficiency rating level. This is the distribution of homes in my sample for both Anchorage and Fairbanks. As you can see, that very few homes in both samples fall into the 1-star, 1-star plus, or the 5-star, 5-star plus, and none fall into the 6-star plus. Because there are few homes in these categories at the ends of this distribution, outliers or influential data points could have an effect on the parameter estimates. And so because of that, I used robust regression in addition to OLS. Robust regression is less sensitive to outliers than OLS is, and I used Stata's robust regression, and that uses iteratively weighted least squares. Robust regression reduces the influence of outliers and high leverage data points on parameter estimates by first dropping the most influential data points and then downweighting observations with large absolute residuals. So the data for this chapter consists of homes that eventually participated in either the rebate or the weatherization program. And the reason I use these homes is because they have energy efficiency, because they have energy ratings, because they were required to have the energy efficiency audits. And I'm not interested in whether or not I wasn't interested in whether or not they participated in either the rebate or the weatherization program. I'm only interested in their energy efficiency rating. And only about 40% of each sample actually had the post-improvement, were assigned the post-improvement rating. So if a home sold after it participated, it was given that post-improvement rating. But if a home sold before it participated in one of these programs, it was assigned its as-is rating. And in order to do that, that's based on 2 assumptions. The first assumption is that the energy efficiency rating of the home did not significantly change between the date of the sale and the date of the energy efficiency audit. And since the study period is only 8 years, that seems reasonable. It's unlikely, all else constant, that the energy efficiency of the home would degrade a great deal in an 8-year period. The second assumption is that owners did not make significant energy efficiency improvements to their homes before they applied to either the weatherization program or the rebate program. And that seems reasonable because these were both publicly funded programs and they were well advertised. So it seems unlikely that somebody would buy a home, invest a bunch of money out of pocket in energy efficiency improvements, and then turn around and apply to one of these programs and then do that again. So based on these assumptions, I have my data for Anchorage and Fairbanks. The independent variables for the housing characteristics are square feet, bedrooms, bathrooms, garage capacity, heated garage, age, and acres. For the Anchorage sample, this information was not made available to me. For my Anchorage results, in the robust estimation, for each 1 point increase in a home's energy score, the home's value increased by 0.3%, and the mean price of a home in the sample, that equates to a price premium of over $1,000, just over $1,000. For the OLS model, the price premium is 0.4%, so for each additional point a home was awarded during the energy efficiency audit, the value of the home increases by about $1,400 at the mean price of a home in Anchorage. when the model is broken out into the various levels. So one thing I'd like to point out first, okay, so these are the robust coefficients, these are the OLS coefficients. You can see for the 1 star, this is a huge difference. And looking at that, that tells me that there were some influential data points in that category that are affecting the coefficient estimates. So I would trust the robust estimates more than I would trust the OLS estimates. What the results show me is that compared to a 3-star home, homes with a 1-star energy rating in Anchorage sell for a 7.4% discount. And then homes with a 5-star rating sell for a 6% price premium. The 5-star plus was not statistically significant. And you'll notice that this dropped. I believe that this is because there are so few observations in that category. The Fairbanks results show me that for each additional point awarded during an energy efficiency audit, the price of a home increases by 0.5%. At the mean price of a home in the Fairbanks sample, that equates to a $1,100 energy efficiency price premium. With the OLS model, a 1-point price increase equates to a 0.8% increase in the price of that home. At the mean price, that is about $1,800. When the energy efficiency ratings are broken out into the star ratings, compared to a 3-star home, a 1-star home sells for a 13.3% discount, and a 5-star home sells for a 12.7% price premium. And once again, you'll notice the drop between 5 stars and 5-star plus, and I believe that's because there are so few observations in that category. So for this chapter, the results show me that home buyers in both markets pay price premiums for more energy efficient properties. The price premium is higher in Fairbanks than it is in Anchorage, and that's not surprising because Fairbanks has both a colder climate and higher energy prices. So the potential energy savings associated with living in an energy efficient property in Fairbanks is greater than it is in Anchorage. Energy efficiency improvements are a good investment if the premium you get when you sell your home is greater than the cost of what you invested into those improvements, or if while you're living in your home, the energy savings that accrue to you are greater than the initial cost of the energy efficiency investments. So the policy implications of this work, for the first 2 chapters based on the rebate program, that program incentivized homeowners to invest in energy efficiency improvements, which has led to an improvement of the housing stock in Fairbanks and Anchorage. Also, one benefit of both those programs and just purchasing an energy efficient home in general is that you'll have reduced household energy costs over living in a less efficient property. And when energy prices are low, it might not make that big of a difference, but in times of high energy prices, when we have an energy price spike, that can make a substantial difference for household budgets. It can determine whether or not somebody is in energy poverty or not in energy poverty. One of the biggest benefits of residential energy efficiency is that it reduces the amount of CO2 that is emitted from the residential housing sector. These studies are not without their limitations. I did not have actual energy cost savings. And the reason I don't have those is because they're not known. They're not collected. It's very expensive to collect that. And all of the energy cost savings are based on engineering estimates. Another potential problem is that the maximum rebate a homeowner could receive was $10,000. So there's no real incentive for homeowners to turn in their receipts beyond $10,000. So even though the average amount that the Alaska Housing Finance Corporation said that a home paid, it was based on the receipts that were sent into them, we don't really know if people spent more than that but didn't turn in their receipts. They don't know. Another limitation is I know that the homes underwent retrofits for the first 2 studies, but I don't know precisely what they did. I don't know what changes they made to their homes. This data is collected, but it was not made available to me. If I did have this data, I could have done a second stage analysis where I looked at the rebate participants, and then I could parse out how individual energy efficiency improvements affect the value of the homes. Lastly, some of these studies suffered from limited sample size. For example, the first study on the rebate, if I would have had a larger sample, there would have been more rebate homes that sold both before and afterwards, and I could have conducted a difference and differences analysis on that chapter, for that chapter as well. And then lastly, there were relatively few homes at either end for the 1-star or the 5-star energy ratings. And so because there were so few homes in those categories, it made it hard to be able to trust the parameter estimates. For future studies, I would like to focus on actual energy cost savings associated with different energy efficiency improvements, and I believe the Alaska Housing Finance Corporation is collecting this information on some homes across the state. I would like to investigate how these different energy efficiency improvements affect transaction prices of houses. So new windows, insulation, a new boiler. If I had the information on what people did to their houses, I could conduct an analysis like that, and I think that would be very interesting, especially for homeowners that are trying to maximize the value of their energy efficiency improvements. I'd like to conduct similar studies to this in other housing markets throughout Alaska. This would be interesting to do in the Matsu Borough and the Juneau Borough. However, this type of analysis can only be used in places that have strong housing markets. In a rural area that does not have many housing sales each year, you couldn't do this, use this type of study. And lastly, the sample size could be increased if all homes in the AK Warm database, for which the state has energy efficiency ratings, if those were included in the sample instead of just homes that participated in the rebate or weatherization program. Are there any questions?
We have a short period for public questions, so feel free to raise your hand and Rob can call on you. Wow, quiet group. Might drop easy. Oh, there's one.
I was wondering, did you adjust the prices for inflation?
Yes,
Okay.
definitely. Yeah.
Chris?
Maybe twofold. I just wanted to check. Remind me again that what interval, time years? What's your study?
Oh, it's 2008 through 2016. That was the
Okay.
time frame that the home energy rebate program was.
About 8 years, ish. Is that
Yeah.
right?
Mm-hmm.
And then it just caught my attention. I was surprised by the churning in the housing stock. Like, can you just summarize for me for like in Anchorage? Do you remember the total number of?
I didn't hear what you said. The what in the
What was
housing
like the
stock?
total number of observations for either of yours, like in Anchorage, just
Oh.
ballpark?
For Anchorage, the full sample had over 26,000.
Yeah.
And then
Okay.
for Fairbanks, let me go back and look. I think Fairbanks was 6,000.
Okay.
So, but Anchorage is so much bigger than
Yeah, yeah.
Fairbanks. It doesn't surprise me that they're.
Okay, and so that's the total number of sales, right?
Mhm.
Okay, then the only final one was, is the sale price public information?
No, it's
came
not. I
to my
had to
attention
sign
that-
non-disclosure agreements and beg and grumble for data.
Well, congratulations. Yeah, somebody mentioned that in this state that home sale prices are not publicly available. Okay.
Yes?
So, in your policy analysis, you were saying that the quality of the housing stock will go up. So do you expect, as the quality of the housing stock goes up, the price premium to go down?
That's an interesting question. So for some of the European studies in areas that had more stringent energy efficiency housing codes, the price premium was smaller than in areas that don't have very stringent ones. And so yeah, I think that as homes become more efficient, these additional energy efficiency certifications would probably add less of a premium to them.
Is the average home size in Anchorage bigger than in Fairbanks?
It is.
Okay, I just saw that in your table. So it's, so you just took all the houses for like that participated in the rebate program, right? And then you averaged those out. So this was not every single house in Anchorage or in Fairbanks. This was just the houses.
For which table are you talking
It
about?
was one of those last.
For the sample mean, it would be all the houses.
Okay.
All
But
the
I
houses
did have, where I did the T-test.
That were sold.
that were sold, okay.
Oh, that was.
Oh,
okay.
yes, excuse me, all the homes that were sold. So I have, is this what you're talking about? Oh, wrong.
Yes.
Just to make it easy on you, Dom.
This is 2200 square feet, something certain.
Is this what you're talking about?
It was further down, but it was one of those tables. Is that the one?
So for the treatment group, the average, it was 2,000 square feet. Then the full sample, it was 1,800 square feet. And then once I used the propensity score matching, the control group had a average housing size of around 1,900.
So is this Anchorage? You had a table where both of them were like next to each other,
Okay, I think that's
further
probably the
down.
last chapter.
Yeah, it was one of those, right? Yeah, there you go. So this is only for the houses that sold
This
and
is,
are part of the rebate.
no,
No.
this is for my full sample.
Okay.
Yeah.
So the,
What?
sorry, the full sample is everything that is in that database, or what's the full
The
sample?
full sample for Anchorage, and this is for the third chapter, this is repeat sales. So this is all homes that sold twice.
Okay,
Yeah.
okay.
Amanda?
So do you think if you provided this information to Alaska Housing Finance Corporation, they would give the receipt information to another researcher that could find actual data or collect more receipts? Would it incentivize them to collect receipts?
I don't think this would incentivize them to collect receipts. They fully understand the problem, and they're actually thinking of ways for when the oil price goes back up, if they ever have another program like this, to try to make sure that they're able to collect all costs. Because the way that this is set up right now, you really have no incentive to turn in receipts beyond $10,000. But at the same time, if you knew you could only get $10,000 back, you're probably not going to spend way more than $10,000, so. Any more questions?
Any questions? All right. Well, thank you for your attendance today. We appreciate it. But we're going to close the meeting for the committee. If you guys have any questions in the future that you think of, feel free to email Dom. She had her email there at the end. I'm sure she'd be happy to answer any other questions that you might have. Also, I know that once the dissertation goes through the process, it'll be publicly available through our library, so you guys will be able to access it there as well. So thank you for coming today.